So in this session we shall go for the remaining portion of module 2. Till now we have completed this couple system. Couple system is done, then equivalent force couple system is also done, and numericals over this equivalent force couple system is done. So this composition of coplanar non-concurrent forces, resultant of forces are already done in module number 1 while solving Varignon's principle. By applying Varignon's principle, these two topics are already done. So equilibrium of system of forces. So in today's topic we shall go for equilibrium of system of forces, and then equation of equilibrium of coplanar force system and condition of equilibrium. So to today class we shall go for these two topics, then we shall come for this free body diagram and law of superposition of forces. So equilibrium. When equilibrium, for example, let us take, there is a ball laying on the floor. If I apply some force F, what happens? This ball will start to move in this x direction. Okay. Then what I will do, I will apply an equal and opposite force in the opposite direction. Then what happens? The ball will comes to stagnation, or it will come to rest. That is, ball will not move from its position. Then it is called as a static equilibrium. So when some external forces are acting on a stationary body, the body may start moving or may start to rotate about any point. But if the body does not start moving and also does not start rotating about any point, then the body is said to be in equilibrium. That is, due to application of these two forces, the body neither moving nor it is rotating. So this body is in a static position. Then it is called as the body is in equilibrium, or the particle is in equilibrium. Next, principles of equilibrium. So principle, this can be either called as a principle of equilibrium or equilibrium of a force system. So how to define this equilibrium of a force system? Let us take here a plane. Let us take this is as a xy plane. Okay, this is x and this is y. Let us take an xy plane in which there are n number of forces are acting in some different direction. Let us take these are the direction of the forces. Few forces which are acting in this plane. So these all the forces are concurrent forces acting in some plane x, y. Now the equilibrium force system, or as per the principle of equilibrium, that what it states is the algebraic sum of all these forces should be equal to 0. That is, algebraic sum of all these forces is equal to 0 means the resultant should be 0 for all the forces, all these forces about this plane, the resultant should be 0. And apart from that, if I choose some point over this plane, about this point, the moment produced by all these forces, that is, for example, this is the point chosen. If I extend a line here, this is the line of action and this is the perpendicular distance. This produces an clockwise movement. If I extend this line here, this is the perpendicular distance and it will produce an anti-clockwise movement. If I take algebraic sum of all these movements, that is moment produced by all these forces, its algebraic sum of all the moments should be equal to 0. Then the system is said to be in equilibrium, otherwise the system is not in equilibrium. Now let us come to the principle of equilibrium. The principle of equilibrium states that a stationary body which is subjected to a coplanar forces. That is, a body which is already stationary is subjected by few coplanar forces will be in equilibrium. This body will be in equilibrium if algebraic sum, that is algebraic sum of all the external forces, that is the all the external forces, that is F1, F2, F3, algebraic sum of all these external forces is equal to 0. That is summation of horizontal forces is equal to 0 and summation of algebraic sum of horizontal force is equal to 0 and algebraic sum of vertical force is equal to 0. That is indicated by this sentence. And also the algebraic sum of moments of all the external forces about any point in their plane is 0. That is, about this plane, if I choose any point about that, if sum of all the moments, that is moment produced by all these forces, algebraic sum becomes 0, then it is called as a principle of equilibrium. So let us see equations or conditions for equilibrium is, that is summation of algebraic sum of forces is equal to 0. The algebraic sum of forces is nothing but summation algebraic sum of horizontal forces and algebraic sum of vertical forces, or in other words algebraic forces in x direction and algebraic forces in y direction should be equal to 0. This is the first criteria. And moment produced, that is algebraic sum of moments produced about a point chosen in the plane should be equal to 0. So this is the principle of equilibrium. Next, let us see force law of equilibrium of different force system. So what this force law? Force law, there are three. One is two force system, three force system and four force system. That is a system of forces consisting of two forces, system of force consisting of three forces and system of forces consisting of four forces. What this force law of equilibrium says? As per the force law of equilibrium, for a two force system, when a body is subjected to two forces, see here this body, let us take this as a body and it is subjected to two forces, then the body will be in equilibrium. This body will be in equilibrium if the two forces are collinear, equal and opposite. This body will be in equilibrium provided these two forces, that is magnitude of these two forces is same and these two forces should be collinear and they should act in opposite direction. Then only the system, that is system of two forces, will be in equilibrium. Now come to this figure. See here, also there are two forces in this system of forces. There in this system of force, what is there? There are force F1 and F2. F1 is, that is this force F1 is equal to F2 V1. Then also this force system is not in equilibrium due to the application of these two forces. Since F1 and F2 is say equal and opposite in direction, so summation of vertical forces will be 0 and there is no horizontal force, so summation of horizontal force is also 0. But see here, due to application of these two forces are acting at a distance apart by x. So these two will produce couple, that is this body will start to rotate, that is it will have some movement, that is summation of m is not equal to 0, then this is not in equilibrium. So what, as per force law of equilibrium for two force system, If the two forces are having same magnitude and are collinear and acting in opposite direction, then only a two force system will be in equilibrium. Otherwise it will not be in equilibrium as per the force law of equilibrium for two force system. Now let us come to the three force system. So see here what is happening in this. If three force system, when three forces are concurrent, the three concurrent forces F1, F2, F3 are acting on a body at a point O. So at this body they are acting at a point O, and the body is in equilibrium. This body is in equilibrium. When it will be in equilibrium, now I will tell. If the resultant of these two forces, that is resultant of force F1 and F2 is, this is the resultant. If this resultant is equal to in magnitude, that is F3 and R are in equal in magnitude and are collinear and should be acting in opposite direction, then only a three force system will be in equilibrium. The resultant of F1 and F2 is given by R. If the force F3 is collinear, if this force F3 is collinear, equal and opposite to the resultant R, if this force F3 is collinear, equal and opposite to the R, then the body will be in equilibrium. Then only this body is in equilibrium, and this force F3, since because of this force the whole system or the body is coming in equilibrium, that is the result, these F1 and F2 are having a resultant R, and this force F3 is cancelling out this resultant, right? Exactly, this resultant is cancelled out by, or this resultant force is nullified by this force F3. That's why this force F3 is also called as a equilibrant. So this definition we have already saw in our previous classes, that is while solving the problems on couple, where we have found out the location of the resultant. For this resultant we have applied, and this is the resultant, and for this resultant we have calculated equilibrant for this resultant. Kindly go back and have the glance on the problems of a couple. Maybe fourth or fifth problem we have solved about this equilibrant. Now let us see if three forces are not active, are not concurrent, then this force system can be in equilibrium or no. This force system usually when applied by non-concurrent forces usually be not in equilibrium. To have an equilibrium, what should happen? The sum of F1 plus F3 should be equal to F2. Then only the summation of vertical forces will be 0, and the magnitude of F2, this magnitude of F2 should be such that, for example, if I take moment about point A, the magnitude of this F2 should be such that the moment produced by F3 and the moment produced by F2 should be algebraically become 0. Then only the system will come in equilibrium. Otherwise this system will not come in equilibrium. So for 3-4 system to be in equilibrium, what is the required condition? The resultant of two forces should be equal and opposite and collinear to the third force. Then only a 3-4 system will be in equilibrium. If the 3-4 system is non-concurrent as shown here, then the summation of this is F1 and F3 should be equal and opposite to F2, and moment produced by all these three forces is equal to 0. Then only the system of force is in equilibrium. Otherwise it will not be in equilibrium. Now let us go for 4-force system. So see here in 4-force system, if 4-force system and the 4 forces are concurrent forces, let us see F1, F2, F3 and F4 are the four forces which are concurrent forces and are acting in same plane. If the resultant produced by two opposite forces, that is F3 and F4 and F1 and F2, are equal in magnitude, collinear to each other and acting opposite in direction, then a 4-force system will be in equilibrium. Otherwise a 4-force system will not be in equilibrium. These are the few laws of force law of equilibrium for 2-force system, 3-force system and 4-force system. Now let us have a glance for while solving the problems. These points are most necessary to solve the equilibrium problems. Okay, so first point is about tension. Okay, let us see here. If a body, these points I have already taught you in introduction to the engineering mechanics. While solve there, I have already taught you once again, so that I am taking here so that you can remember while solving the problem. So see here, if two forces equal, if there are two forces acting in opposite, let us take this as F1 and F2, or let us take F1 and F2. Let us take these two forces are acting on a body and they are stretching the body. So this body is in tension. Because of application of force, there is a response developed in the body and the response developed will be away from the point of application of force. So these are the point of application of force, and the reaction developed in the body is acting away from the point of application of force. Then the body is said to be in tension. So will you remember, if body is subjected by external forces, that is if the body is in tension, then the reaction developed in the body will be away from the point of application of force, then the body is said to be in tension. Now vice versa, for compression what happens? It is exactly reverse to this. If two forces are acting here, let us see here F and F. So what happens? The response developed will be acting exactly in the direction, exactly at the point of application of force. Then it is called as a compression. And one more thing, remember, anywhere in the problem, if it is given cable, wire, string, rope, then take it as that the body will be in tension only. For example, this is a string subjected by pendulum, and if I apply some force F, this string will be in tension. Obviously this is fixed at one point and this weight is acting in downward direction, that is one force is acting upward, another force is acting downward. That's why this string will be in tension only. So in this manner, if anywhere you find cable, wire, string, rope, then take them as granted as they will be always in tension only. They cannot take a compression. These string or wire, or they will not be able to take compression. For example, if I apply a equal and opposite force, what happens? This will get disturbed like this. It will get distorted like this. So these things will not take any compression. So these members should be usually in tension only. Next, tension in the string remains same on both sides when the string passes over a frictionless pulley. For example, this is an pulley, frictionless pulley. If I am applying some force or I am attaching some weight here, okay, let us take it is lifting some weight of W, and this rope is passing over an frictionless pulley, then the tension here will be equal to the tension in this string. That is, tension in this string, that is right side of the pulley, will be the same as this tension will be same here in left side of the string. That is, if a string is, or if a rope or a wire is passing over an frictionless pulley, then the tension on the right side of the string. If the tension is equal to, for example, 10 kilonewtons, same tension will be there in the left side of the string, that is on the left side of this pulley. Now last one is the reaction are directed towards the centroid of the body. This will we will get a clear picture while solving the problems. Just remember that reaction are directed towards the centroid of the body. For example, this is the circular body, this is its center. So usually the reactions are usually directed toward the centroid of the body. So in the next class we will go for Lami's theorem, and before going to the Lami's theorem we should require some basic knowledge of law of triangular forces and what is the sine rule. Then we will go for Lami's theorem in my next session. Thank you.